Good day. We are the group 5 Vibe.
Five in the air, let's do it together. Five to the side, who cares about the weather? Five on the floor, the party's on at your place. Five to the front, there's a smile on my face. One, two, three, four, high five. One, two, three, four, high five. One, two, three, four, high five. Five in the air, let's do it together. High five.
We are here to present our current project in architectural structures entitled A Comparative Analysis of Architectural Design in Concrete Structures, exploring heritage and historical masterpieces in the Philippines, Southeast Asia, and Asia.
Starting off with historical overview, research on concrete development in the Philippines. The development of concrete in the Philippines reflects the country's historical progression, incorporating indigenous ingenuity, colonial influences, and modern advancements. Following presents the evolution of concrete from traditional construction practices to its contemporary applications. First is pre-colonial era, wherein before the introduction of modern concrete, early Filipinos utilized indigenous materials like bamboo, nipa, and adobe for construction purposes. Pre-colonial structures such as stone fortifications and foundations relied on basic binding techniques involving lime and other natural adhesives. During the Spanish colonial period, construction techniques were introduced to the Philippines, including the use of lime-based mortar and early forms of concrete. Spanish friars and engineers utilized mortar in the construction of churches, fortresses, and government buildings. Notable examples include the San Agustin Church in Intramuros, which combined coral stone with lime mortar. During the American rule, the Philippines experienced significant infrastructure development, which heavily relied on reinforced concrete. Portland cement, crucial for modern concrete, was introduced by the Americans to build bridges, roads, and buildings. Iconic examples of American-era concrete structures include the Manila City Hall and the Quezon Memorial Circle. This period also marked the start of urban planning initiatives that incorporated concrete as the main building material. After the destruction of World War II, the Philippines underwent extensive reconstruction efforts where concrete became a symbol of resilience and modernization. Both the government and private sector focused on constructing sturdy buildings to withstand future conflicts and natural disasters. This area witnessed the rise of mid-rise residential buildings, public schools, and government offices, all heavily relying on reinforced concrete. Today, concrete usage in the Philippines is characterized by innovation and sustainability. Advanced techniques like precast concrete, high-performance concrete, and self-healing concrete are becoming more common. The construction of high-rise buildings such as skyscrapers in Makati and large-scale infrastructure projects like the Metro Manila subway demonstrate the versatility and strength of modern concrete. Furthermore, local companies are exploring green concrete alternatives such as using fly ash, slag, and other industrial byproducts as supplementary cementitious materials. The development of disaster-resilient concrete designs also reflects the country's focus on mitigating the impacts of earthquakes and typhoons.
Concrete has played a vital role in construction since ancient times. Originating from materials like burned limestones and gypsum, it was first used as mortars by civilizations as early as 1300 BC. The Nabatean traders around 6500 BC developed early concrete-like structures, discovering hydraulic lime to create durable mortars for walls, floors, and cisterns. In Egypt, around 3000 BC, gypsum and lime mortars were key in constructing the pyramids, ensuring precision and stability. In China, innovative uses of concrete extended to both building and monumental structures like the Great Wall. The incorporation of sticky rice into the mortar demonstrated their resourcefulness, withstanding centuries of environmental challenges and demolition attempts.
Located in Manila, Philippines, Cultural Center of the Philippines is designed by architect Leandro V. Locsin. It is established in 1969. Known as the primary venue for arts in the Philippines, organizing and showcasing various forms of arts such as music, dance, theater, visual arts, literature, film, and design from both local and international artists for over 4 decades. The Tanghalang Pambansa exemplifies Leandro Locsin floating volume style, inspired by the Nipa hat. Its brutalist facade features a travertine block suspended by cantilevers, creating a floating illusion. The building houses theaters, galleries, a museum, and a library. The structural system of the Cultural Center of the Philippines play a vital role in its design, ensuring the building's safety and structural integrity. This system not only provides stability, but also seamlessly complements the building aesthetic, reflecting the harmony between function and visual appeal in Philippine architecture. The Cultural Center of the Philippines Theater of Performing Arts is a landmark blending modern architecture, cultural identity, and Philippine history. Designed by Leandro V. Locsin, it features bold geometric forms, clean lines, and a cantilever design that creates a floating illusion. Luxin combined global modernist principles with Filipino elements like capichals, reflecting the nation's balance of tradition and progress. Vijay Kita Community Center in Kalana Jaya Park is a sustainable youth-focused space spanning 4.3 acres. It features patios, retail space, and shipping containers, a food hall, sport fields, and skate parks. The center features accessible circular glass structures and modular tea canopies inspired by rainforestry. The 60-meter central walkway concept key spaces, offering shade, ventilation, and a vibrant hub for activities, all while blending harmoniously with nature. The center uses a modular tea canopy, combining steel and lightweight concrete for sustainability and flexibility. Irregular concrete columns support glass structures, balancing design and function. The structure's foundation is reinforced with minimal environmental impact, allowing for expansion and adaptability. Concrete elements enhance durability while maintaining a flexible, eco-friendly design. The center is a dynamic space designed to evolve with the needs of its citizens, fostering unity and participation. Created by DTLMA, it reflects the community spirit through inclusivity, cultural exchange, and social responsibility. The center serves as a hub where people and place converge, creating lasting connections and cultural significance for future generations. The Vijay Kita Community Center's architecture blends adaptability and inclusivity, fostering unity and cultural exchange. Its design meets both functional and social needs, creating a lasting space that reflects and grows with the community.
Located in Ibaraki, Japan, the Church of the Light, designed by Tadao Ando in 1989, is a minimalist masterpiece. Covering 113 square meters, it captures the delicate balance between light, space, and spirituality. Tadao Ando's design focuses on simplicity and the interplay of light and shadow. The iconic cross-shaped void carved into the east wall invites natural light to transform the dark concrete space into a spiritual sanctuary. The church's structure is a reinforced concrete box measuring 18 by 6 meters. Its smooth concrete walls, built with tatami-sized panels, serve both structural and aesthetic purposes, reflecting Ando's commitment to material honesty and craftsmanship. Light is the core of this design. The cross-shaped cutout is more than a symbol. It directs light to define space, guiding visitors toward spiritual reflection without relying on traditional Christian symbols. The church embodies the Japanese concept of ma, valuing empty space to evoke calmness. By blending Christian symbolism with Japanese minimalism, Ando creates a space that transcends cultural and spiritual boundaries. Tadao Ando's Church of the Light continues to inspire architects worldwide. Its balance of form, material, and emotion reminds us that architecture can move beyond function to touch the soul. The Church of the Light stands as a testament to the power of simplicity. Through raw concrete and pure light, Tadao Ando invites us to experience a space where architecture becomes a spiritual journey.
Concrete is a cornerstone of modern construction, valued for its strength, versatility, and aesthetics. For massive infrastructure to intricate designs, it's an essential material. The focus on three key aspects is durability, adaptability, and artistic uses. Durability. Concrete's strength support heavy loads, and its weather resistance ensure longevity. It often lasts over a century. Some of the challenges, like chemical attacks, are mitigated with sealants and admixtures. This enhances its durability. Adaptability. Concrete's properties can be customized with innovations like self-healing and ultra-high performance concrete. It's moldable for intricate designs and sustainable practices like recycling and reducing waste. And artistic uses. Concrete's plasticity allows for both architectural designs and unique finishes, while its durability makes it ideal for sculptures and public art. In conclusion, concrete's durability, adaptability, and artistic potential ensure it remains indispensable in construction and design.
Concrete has long been a cornerstone of the construction industry due to its strength, durability, and versatility. However, as a traditional concrete faces challenges such as durability concerns, maintenance costs, and environmental impact, modern architects and engineers are exploring revolutionary innovations that expand its applications while addressing its limitations. Ultra-high performance concrete offers superior strength, fire resistance, and longevity. Lightweight yet durable, it reduces transportation and installation costs, excelling in harsh environments like bridges and facades. Next, the self-healing concrete. Minimizing maintenance costs, this type of concrete uses embedded agents like bacteria to repair cracks autonomously. This innovation ensures longer-lasting structures, reduces repair time and cost while promoting sustainability. Next is a self-cleaning concrete. This photocatalytic concrete incorporates titanium dioxide and breaks down pollutants on its surface when exposed to sunlight. This not only keeps surface clean, but also improves air quality, making it a game-changer for the urban construction. Transparent concrete. By embedding optical fibers, transparent concrete combines aesthetic with functionality, enabling natural light to illuminate spaces while reducing energy consumption. It's a blend of creativity and sustainability in modern architecture. Next is a smart concrete. This type of concrete integrates IoT technology to monitor structural health in real time. This innovation improves safety, reduces maintenance costs, and supports the development of intelligent cities. Next is the green concrete. This uses recycled materials and industrial byproducts to reduce its carbon footprint. Innovations like carbon capture and thermal-regulating components enhances its sustainability and performance. 3D printed concrete. This transforms construction by enabling the creation of intricate design with reduced waste and faster project timelines. This technology addresses labor shortages and revolutionizes custom construction. Then last is the modular and prefabricated system, which improve efficiency, reduce construction time, and offers scalable, cost-effective solution. They are particularly useful in disaster-prone areas and high-demand housing projects.
First, the Cultural Center of the Philippines Theater of Performing Arts. Culturally, it promotes Filipino heritage through theater, dance, and music, supporting both traditional and contemporary arts. Geographically, its location along Rojas Boulevard near Manila Bay provides scenic views and an inviting atmosphere for cultural events. Environmentally, its open spaces and concrete structure allow for natural ventilation and resilience to Manila's tropical climate. Next, the PJ Kita Community Center in Malaysia. Culturally, it fosters community engagement by incorporating local art and supporting small businesses. Its placement within Kalana Jaya Park blends with green spaces, encouraging multifunctional use. The tropical design with T canopy structures ensures natural ventilation and shade, fitting for Malaysia's hot and humid climate. Lastly, the Church of the Light in Japan. Culturally, it reflects Japanese minimalism and Christian symbolism. Geographically, its quiet suburban setting promotes a reflective atmosphere. Environmentally, reinforced concrete regulates temperature and the building's orientation maximizes natural light, reducing energy use. These examples show how cultural, geographical, and environmental factors directly influence architectural design.
The Cultural Center of the Philippines reflects a harmonious blend of modern Filipino identity and traditional architectural elements, balancing form and function to symbolize cultural pride and artistic expression. Its innovative floating volume design, inspired by nipa huts, uses cantilevered beams and crushed seashell-infused concrete to connect the structure to its cultural roots. Similarly, the PJ Kita Community Center in Malaysia emphasizes inclusivity and adaptability, fostering community engagement through open spaces, courtyards, and permeable facades that enhance natural ventilation and lighting. Finally, Tadao Ando's Church of the Light in Japan showcases a minimalist design philosophy using light and shadow to create a profound spiritual experience. Its smooth, shuttered concrete forms a meditative space with the iconic cross of light, transforming simplicity into an emotionally powerful architectural statement. Together, these case studies highlight how design philosophies and innovations can shape culturally and emotionally resonant spaces.
Moving on to the modern implications on design based on the analysis of 3 case studies, Tanghalang Pambansa located in CCP Complex in Pasay, which is designed in the brutalist style, showcases concrete as a primary material to convey power, timelessness, and structural integrity. While concrete ensures durability as evidenced by the building's 53 years of existence, its high thermal mass raises sustainability concerns in the Philippines' tropical climate. The heat retention and slow release by the concrete facade may compromise the interior comfort and the building's environmental efficiency. In terms of heritage sensitivity, Tanghalang Pambansa integrates vernacular elements by mixing concrete with materials like shells from the reclamation site and drawing inspiration from traditional Filipino structures such as nipa hut to create a floating volume aesthetic. Despite these contextual adaptations, the brutalist architectural style and the extensive use of concrete are less compatible with the Philippines' tropical climate. Historically, early Filipino architecture emphasized climate-responsive materials and design, underscoring a mismatch between the chosen style and the country's environmental needs. Next is the PJ Kita Community Center. Uses durable, low-maintenance exposed concrete, minimizing finishing materials and environmental impact. Locally sourced materials reduce transportation emissions, combined with passive design strategies like large openings for ventilation and daylighting. The concrete's thermal mass regulates indoor temperatures, lowering energy use. In terms of heritage sensitivity, the PJ Kita Community Center uses concrete to blend modernity with Malaysia's heritage, incorporating perforated screens and open layouts inspired by traditional tropical architecture. This approach merges practicality with cultural and climatic sensitivity, honoring Malaysia's architectural identity. Next is Tadao Ando's Church of the Light, where it features exposed reinforced concrete, emphasizing precise formwork to minimize waste and eliminate the need for cladding, reducing embodied energy. Concrete's thermal mass stabilizes indoor temperatures, while large openings flood the interior with natural light, reducing daytime energy use. In terms of heritage sensitivity of the Church of the Light embraces concrete with a minimalist philosophy, reflecting Japanese values of simplicity, spirituality, and harmony. The stark walls emphasizes light and shadow, echoing traditional aesthetics like wabi-sabi, while respecting Japan's heritage of spatial storytelling and mindfulness.